So just to kind of break into Constructal Law a little bit, in Design and Nature, you define Constructal Law as for a finite flow system to persist in time, parentheses, to live, its configuration must evolve in such a way that provides easier access to the currents that flow through it. And I was just wondering if you could break down this definition, or even just before that, could you actually come to the genesis of how you got to this definition of Constructal Law?
Well, it was, by the way, I wrote that law in 1996 in two articles
Yes.
that year. And so this is already 2 decades after my, no, actually 96, yeah, 2 decades after my PhD. And during those 2 decades in engineering science, primarily because of the energy crisis of the early 70s, there had been a revival of interest in the laws of thermodynamics, which means that thermodynamics was, anyway, a more active field in itself. And so much so that even the U.S. Congress was having hearings on the subject of energy conservation and how to increase efficiency here and there. It was as if the Congress had become one of the halls of MIT. You know, in other
That's
words,
funny.
my own professors were testifying in Congress. Okay, uh, and um, and so much of being on display. This kind of topic attracted interest from others, from biology. People from biology started to talk about the thermodynamics of the animal design, but also from economics, because economics, everybody knows it's about uh, making life easier, more economical. Uh, yes, everybody's interested in lengthening the lifespan. That's the medical profession. So there was a bigger thing uh, taking shape around the simple subject, the beautiful two-page science that I was taught, because thermodynamics is a two-page science, first law and second law. That's it. There are no drawings in that book with 2 pages. And Adrian, now wait a second. And I was actually involved in expanding this sort of applicability of thermodynamics. Colleagues of mine would call it thermoeconomics. I mentioned uh, uh, biothermodynamics and all these things. But I forgot to tell you that when I was a little boy, I was also trained in the graphic arts. I was taught how to draw. I have an inclination in that direction. So it occurred to me that all these people who had come from the outside were in fact very similar to the inventors of engines from the 1700s. People know about James Watt, but he was 100 years after the invention of the steam engine. Were actually doing the same thing. They were about the economics or the economic living of the person or of the people in the coal mines, and they were coming with drawings. They're coming with drawings. And well, the laws of thermodynamics are not about drawings. They're not about every single, those two laws are about two phenomena. The first law is the phenomenon of what goes up must come down. That is conservation of energy, known from the 1700s, even earlier, in mechanics. So the idea is this, that one law is about one phenomenon. I just told you what the first law is and what its phenomenon is. The second law, which I stated in 1850, is about another distinct phenomenon, which is that of irreversibility. Everything by itself flows from high to low, not the other way around. You can fill in the blanks with the words or the language that you know. Say water flowing downhill, heat flowing from hot to cold, and so on and on and on. Yes, so those are two phenomena and two laws. But in this avalanche of interest from these real people, people who actually work on making life easier. I mentioned economics um, in late 70s and early 80s, were coming up with okay, city design, with how to create a supply route to be more efficient, how to how to design the air traffic grid. And these are drawings, man, drawings. And then you look at the book of biology, it's drawings. All of it is drawings.
And
And that's
figures.
and that's the thank you for saying it. So yes, so there are figures all over nature, and that is the phenomenon. There's a phenomenon that like the elephant in the room is everywhere. It is well known. Everybody knows. Says everybody knows that, uh, but it is not recognized as a phenomenon. And so the phenomenon of design in nature, but by the way, design is not still art. It is actually changing all the time. It's a movie. Everywhere you look, it's a movie. Even let's say, dead thing here, dead thing came from somewhere to be here. So this is moving, and from Adrian, it becomes empty, and then it gets thrown into the recycle bin. It is actually in motion and in continuous transformation. Um, so I said, what's missing here is the obvious, which is the phenomenon of design change. I come from a Latin language, Romanian. That means evolution, okay? So evolution is a phenomenon of all nature. It is not, well, even better, evolution, the word was not coined by Darwin. In everything that I do, Darwin is not needed, you see. Darwin, yeah, Darwin, or especially his disciples and now copycats, are describing what they see. They are not predicting.
Mhm.
But
Yes, you
if
mentioned that in your books.
yes, but if you have the so-called summary of the phenomenon, which in this case is called the Constructal Law, if you have that statement that you read, that you know how to predict the appearance of these forms before you look at them. And that is extremely powerful, to predict what will hit you before it hits you, meaning to see to see ahead, forward, and also to see ahead of time.
Right.
Think about
S-
that.